Okay, so yesterday we talked about solving system of equations by graphing. And we did do easier versions of that, okay? One of the equations you had to graph using your slope and y-intercept. The other one was usually just y is equal to a number, x is equal to a number. And today's graffiti would have reviewed that because I think a lot of you did struggle with that for whatever reason. But now you do have a reference for that, okay? So today we're going to continue talking about systems of equations, but we're going to get a little bit more into it, okay? So yesterday we talked about graphing two lines, okay? And we said that the point where those two lines intersect or cross each other is called the what? Jordan?
Is it called the origin?
Not the origin. The origin's where the two axes cross. Isel? It is the solution point. Very good. So the point where the lines meet is called the solution. So yesterday we did all examples that have lines that intersect, right? Does everybody agree with that?
Mm-hmm.
Yes? So how many solutions were there for each one of those examples that we did?
It was like an ordered pair.
It was an ordered pair, but there was one specific point, correct? So that means when we have lines that intersect, we have one solution and one solution only. I'm going to draw a little sketch that you're also going to draw. It doesn't have to be perfect. And where those two lines cross each other is your solution, which is x, y. Okay, now think back to chapter 2, when we solved all different types of equations. Did we always get x is equal to 1 or y is equal to 7? No. What other type of answers did we get, Jackie?
You can get fractions, decimals.
Well, yes, all different kinds of numbers, all rational numbers. But what else did we sometimes get? Nobody? Did we sometimes get 3 is equal to 2?
Uh-huh.
Yes, we did. And what did that tell us? Was 3 ever equal 2? So that meant that there was no solution. So when we're doing this as well, we're also sometimes going to have no solution. So what do you think those lines are going to look like? No solution. Adriana?
They're not gonna
They're not going
intersect.
to intersect. What are two lines? What? Parallel lines. Very good. So sometimes we're going to have parallel lines, which tells us there is no solution for that problem. We also said those lines never intersect. That's why there's no solution. I'm going to draw a little graph. Let's take a look at these two lines. Let's make some observations about these two lines. What do you notice? What's that? They're straight lines. They are linear. Very good. What are the two things that we need in order to plot a graph? Huh? You can have an ordered pair, but as of more recently, what are the two things that we need? Huh? What are the two things we need in order to graph a line? What? The rise of the line, which is I need the slope and I need the y-intercept. Let's look at the slope and the y-intercept for both of these lines. Okay? The y-intercept for the red line is a what? What kind of number? Is a positive number, and the y-intercept for the blue line is a negative number. So are the y-intercepts the same? No, the y-intercepts are different. Let's look at the slope. What do you think about the slope? What observation can you make? They're both positive, very good. Anybody at all? What do you think? You know the y-intercept is going to be different. Is the slope going to be the same or different? If they're going up, if they're never going to cross each other, they're going to be the same. So they have the same slope, but different y-intercepts. And that will save you some time down the road, because if you identify that they have the same slope but different y-intercepts, you don't have to do any work. You can automatically say that there's no solution. You won't have to go through all the graphing. And there is a third type of scenario that we'll come across. So far we've had lines that intersect at one point. We have lines that never intersect. What do you think the third one's going to be, Haley?
Infinite solutions.
Infinite solutions. Good. What are those lines going to look like? What's our graph going to look like? You don't know? Want some help? Amreen?
It's going to be like one line.
Exactly. They're going to be lines that overlap each other. Very good. So we have overlapping lines, which means infinite solutions. So if they are the same exact line, what do we know about the slope and the y-intercept? Yep, they're going to be the same. So the slope and y-intercept are the same. Right? Because if you choose any point on here, it's going to be the same for... Exactly.